All right, let's roll into things here. Happy Thursday, everyone. Hope everyone's having a good week so far. Topics this week are anything that you want to review from previous weeks. And if we don't have a full hour's worth of content, then I want to talk about writing tests because I think it's really important. And we kind of brushed on it maybe 2 weeks ago or 3 weeks ago. I honestly forget. But we didn't actually write any tests. And I think there's a lot of really interesting things that we can pull out from the progression of writing tests. But that's only if time permits. For now, it is up to you guys. If you have anything you want to review. I see Jenny is asking about useEffect. We can definitely run through a useEffect really quick. We'll start there. Oop. This is sandbox. All right, here we are. Okay, so useEffect is a hook that we can add to our code that listens for a specific piece of state to change and runs some sort of side effect, which is why it's called useEffect. So if I have a piece of state where I'm keeping a count of some object, and I don't know, I have another piece of state here called random string, random string. And let's say I want to keep track of the number of times that, or the number, I don't know, we're doing something with one piece of state that depends on the other piece of state. So let's say this count is the number of, I don't know, the number of times that we've regenerated this string. We're going to do this not the smart way, but in a way that proves a point. So I have my paragraph down here that says we've generated this string count times. And then down here, we're going to add a button on click. We will execute a function, and this function is going to set count, or sorry, set random string math dot random, and then we'll turn it into a string. All right, so this is going to generate a random number, turn it into a string, and then it will set our random string up there. Let's display our random string. Cool. So in this example, every time that I click this button and update this random string, I want to listen for when this piece of state changes and run some sort of side effect which increments our counter. The way that we would want to do this is using a useEffect hook, where I declare a function, and this function is going to call set counts plus 1. Note that we could totally just do this down here as part of this on click, but we're going to do it a different way. So we have our useEffect. It listens for some piece of state to change, and the pieces of state that change are anything that's in your dependency array here. So in this case, I want to listen for when count changes. I could listen for other variables too. I could create an infinite loop here by listening to count. Sorry, we want to listen to random string changes. Or I can leave this empty and say, do something one time at the very beginning when this component is first rendered to the screen. And this, when it has an empty dependency array, will only happen once. By comparison, if I do a useEffect and I don't put anything in the dependency array and just completely omit it, then this useEffect is going to run every single time the component renders, which defeats the purpose of using the useEffect. You might as well just write your code outside of any hook. Since when a component renders, it just runs through the function anyway. So if I were to run this and then go to this in my browser, what did I do? Oh, I have a erroneous backtick. Cool. And every time I click this, it'll regenerate my number and it'll increment our count. And we should only see that first render got printed and the page first renders and no other time that it changes. Yes. It is used to execute a function when the dependencies change. So let's look at this piece of code here and try and understand what's happening. I'm going to swap back to my to-do app and paste it in so that it gives me fewer errors, hopefully. So for your assignment, what we did is we replaced our use semi-persistent state hook by just putting our state back into our app function. And then we take this useEffect and we're going to put that back into our app function as well. So it listens for changes. So I'm going to copy these useEffect hooks back in here.
No.
Cool. All right, set is loading. What else do we need? All right, so this is the assignment that you guys just worked through. As a re-explainer, what we're doing here is we are declaring a useEffect with an empty dependency array, which means this happens the very first time that our component renders to the page. And it's going to execute this function when that happens. And this function creates a promise. I think we might have to return this new promise for this to work. Maybe that's possibly what's causing confusion. Nope, we don't return anything. It's a useEffect. So we create a promise which just says, I have some code that I'm going to run, which is this function here. and I'm going to run this code, and I don't know how long it's going to take. It could go for several minutes. It could be instant. It could be just a couple seconds. Who knows? And when this happens, I will know that it's finished because the user who wrote this code either will call resolve, which is a function, or reject, which is another function. One of those two things has to happen in order for all the code that depends on this promise to work. So if I call resolve at some point in this promise, then anything that runs in a then block that is attached to the promise is going to execute. You can have multiple then blocks, as we'll see next week. And in the end, you have usually one catch block, and sometimes you might want to use a finally block. So your then blocks will execute in order, and it'll wait for this promise, and then it'll do the first one, and then the second one, and then the third one. And if any of them throw an error, or if I reject this promise instead of resolving it, then it's going to go straight to my catch block, and I can handle my error here. And then finally, if you have something that needs to be cleaned up, like maybe you have a subscription to some data that's being fed to you that you want to close down the channel that it's using, then you would do that in a finally block. So in this case, we have our promise. We are going to set a timeout, which again creates a promise essentially that says after 2 seconds, now you run this code. So we're setting an arbitrary delay here to say resolve 2 seconds later, just for the sake of not doing it right away. And when that happens, then we resolve, which passes data out of the promise and says the promise executed successfully. Go to my then block, and we give it an object, which will be this result here. So this object, our assignment says, pass it a data property, and then the data property has to-do list, and then to-do list is your list of to-dos. This should be loaded from local storage. This, I think, was missing from the instructions and caused some confusion this week. But right here, instead of passing an empty array, we already have an empty array up here in to-do list. This is where we want to do our local storage get item saved to-do list. And JSON. Wait, actually, we don't do anything else there. Or an empty array if we didn't find anything. So this was previously what we had in our use semi-persistent state hook. We repurpose it and then get our stuff 2 seconds later. And then we save it to our list, and we can say we're no longer loading. We don't have to pass in a resolve and reject to this promise because this is just the scope of where they exist. They don't exist outside of this promise, but they exist everywhere inside of this function. These are parameters to the function, and this function just so happens to run another function, which is the set timeout. But anything inside of this promise can still access resolve and reject. If you like really wanted to, you could pass in resolve and reject here. Actually, I don't even know if you can do this. No, you can't. So this function inside of set timeout is not supposed to have any parameters. I don't think. That's what it looks like to me. It's just a function that runs and does something. And so we can use a resolve and reject here. This promise, this set timeout, we're not resolve or rejecting this timeout. This is just something that's going to run in the future, and it doesn't matter if it worked or it didn't. It's just going to execute code. The only thing we have to resolve is this promise, the one that we can see. The set timeout happens under the hood. All right, any other questions? Anything else we can review? Yeah, in this case, we don't have any need for rejecting just because We don't have anything that can possibly fail. Usually this promise would be something that's going to like go away and fetch some data somewhere, in which case there's 1,000 different ways that could go wrong. Maybe we don't reach the server that we're expecting, or our connection gets dropped, or so on and so forth. In that case, we would want to reject to say this promise did not finish completely. But for this stupid example, there's no way that this will ever not work.
So we don't need to put the reject in promise constructor.
Yeah, I think you could just take it out entirely if you want to and just leave this first parameter. JavaScript is kind of weird where you can declare as many parameters as you want, and then you can pass as many parameters as you want. Like you could have a function that has 2 parameters, but you only pass it 1, and the second one will always be undefined. And the other way around too. If you have something that takes 1 parameter and you pass it 2, then it just will discard the second one. Convention in other places, I think, is to use an underscore to say, I don't care about this value. I'm not going to use it. So you could do that if you want to, although my linter is still complaining that I'm declaring a variable that's unused. In other languages, this is more accepted than JavaScript. Maybe in this case, the better solution would be to just get rid of that second parameter.
I just updated code according to inputted local storage in the to-do list use effect, right? But still my list is not showing after I reload the page.
Let's test this here to see if this works.
I will try it.
Maybe there's a typo somewhere. Who knows?
Yes, I think it's typing. Yeah, let's see.
Oh, what did I do? To-do list.map is not a function. All right, when my promise resolves, I'm doing something wrong. Oop. Come on. Object.data.to-do list. I gotta do a JSON parse. All right, I'm gonna leave this be and not mess with this too much since you guys have already done this homework. All right, the second use effect, again, listens for pieces of state to change. So this use effect runs every time your to-do list changes, and also every time our loading state changes. So if we say we're no longer loading, or now we are loading, this will also run this use effect. More importantly, though, when our to-do list changes, because we added a new to-do list, a new to-do, or we removed one, then we're going to say if we're not loading, which means let's wait until we've actually loaded up our to-dos from storage first, so that we don't run this where our to-do list is empty. If we're not loading, if we're finished loading, then every time I change my to-do list, I want to set my to-do list in storage to be the new to-do list. So every time the item changes, it adds the next item into your local storage, so that when you refresh your page and this other use effect runs, then it's able to retrieve the most recent copy. Cool. Anything else while we're here?
So my list is still not showing. Please allow.
Okay, you want to screen share really quick, just so we can
Yes,
debug?
yes, I can share this. So here is okay.
Cool. So you have a useEffect. If loading is false, then you set to local storage. That looks good to me. And then on your other useEffect, set is loading true. New promise, resolve or reject, set timeout. And then we're going to resolve after 2 seconds and set our data. Okay, I think this is where we got, and then I messed up, and what happened is I did not parse JSON.parse that local storage.get item on line 19. So this is just going to get a string, and then you're treating it as an object, which is not going to work. So like on line 32, where you do JSON.parse local storage.get item, you did JSON.parse up there as well. See how that goes.
Oh, it's just- yeah, it's showing now.
Cool.
It's working.
Nice.
Thank you.
Of course.
I will stop sharing.
All right. Last call for review questions. Could be about any topic. Doesn't have to be anything recent. All right. In that case, let us talk about some cool testing stuff. Right, I'm going to close this out. And I'm going to send you guys some links in the Zoom chat that you guys might be interested in reading through at some point in the future. We'll kind of briefly go through them here. And I will try to put them in the agenda once we're finished. So let me reshare. Cool. All right. So a quick recap of why we write tests in the first place. When you write code, especially at a very large scale, unlike what we're doing for these homework assignments, you cannot afford to have to manually check every time you write new code that all of your old stuff still works. It is basically guaranteed that when you write new code, you're going to break old things accidentally. Or you're going to write code that has bugs that you don't know are bugs yet because you haven't like released the code and it is in a working state. So you don't really have anything great to compare against. So we write tests, at least I personally write tests for my job for every single piece of code that I release. It needs to have at least enough tests that prove to me and to my coworkers that the code that I wrote works. And it needs to have tests so that when people make modifications in the future to the functionality of the code, those tests are now going to fail to indicate our expectations have changed. What are our new expectations? Are these tests failing because they should be failing and we need to change them, or are they failing because we accidentally messed something up and we need to fix it? Usually it'll be that second case. Jenny, I'm going to hold that question since we already jumped into something unrelated until the very end. So remind me at 8 o'clock to answer that question, please. And yes, I will post these in the Slack and in the Notion afterwards. So in React, most of the time what you'll be doing is you'll be writing components, functional components, but that's not all you're going to be writing. You're also going to probably be writing just some miscellaneous functions that maybe I put in like a util folder here. And inside this util folder, I might have some random functions that do important stuff for my code. I'm trying to remember what I made this do last time. So let's say I had a function here that I'm using somewhere in my app that takes a string and counts the number of occurrences of each letter of the alphabet. And somewhere in my code, I'm going to actually use this function. Well, this function probably has a bunch of sort of scary looking logic in there. And when I write this function, I better know that it's going to work. So I'm going to just write a very naive approach of this function really quick, using something called a frequency array, which is something you will probably use many times in the future. So what I'm going to do is I'm going to push a 0 in here 26 times. And so the 0th element represents how many times A occurs. And then the first element represents how many times B occurs, so on and so forth up until 25, which is C. And then what I can do is I can loop through my string here. Let I is equal to 0, I is less than a string length, I plus plus. And we will say C is equal to a string. The char at method is what we're going to use, and it's going to return the character at a specific index. And we'll get what's at index I, and then we will create an alphabet here. Which again corresponds index to letter. And we will get position as alphabet.index of C. And then we will say frequency position increments by 1, and we'll return our frequency array. Cool. I think that this code is going to work, maybe. But until we run this manually, we have no way of knowing if this is going to work. And I could just like run this file and pass it a bunch of different strings and see if they work. But what I would like to do is I would like to be able to write tests that will automatically run when I push my code or when I run a script that executes them, and it'll just instantly run all of my tests. And I know like 99%, if the tests all work, then my code all works. Maybe I wrote a test that doesn't work. Maybe I don't have enough tests and I'm not catching a specific case. But generally, if I run all my tests, I should expect that it's going to work. Okay, so what we need to do is we need to go into our documentation and make sure that we are installing everything we need in order to write our tests. So we're going to use a library called vtest, which is specific for Vite and plugs in really nicely with React applications so that we can write our tests. So that said, I'm going to pull up this documentation page, and we are going to npm install vtest. And I'm going to save this to dev, which means this is a dependency that I'm only going to use when my code is on my computer in my editor. This is not something that my application is actually going to use when it's deployed and running somewhere in the cloud. So this package comes with lots and lots of really cool stuff that we get to use. And we're going to set it up first, and then we'll talk about how we actually write tests. So we have this package, but we need some way to actually run our tests. And the way that they recommend doing it is by adding another script. So if we go into our package.json, you'll notice that we have lots of scripts up here. We haven't really touched these, but we have been using npm run dev, so on and so forth. And we could write our own scripts. We could write anything we want. We could write a script that literally just echoes hello world to the console. This isn't very useful though. So we can write our test script, and this is going to run vtest. Let's see what that does before we get any further. No test files found. Cool. So it did work, but we don't have any test files. A test file is something that we write .test.js at the end instead of just .js. So we need to do a couple more things here. They have some other recommendations for setting things up. We want to enable JS DOM, which is really important so that we can test React components. We'll hold off on this just for a second, and we'll come back to that. I don't know if we're going to have time to talk about testing your actual React components. Maybe we'll do it very briefly, but I think the fundamentals of testing just a regular JavaScript function do a better job of explaining important stuff. IMO. Okay, so I'm going to turn that off for a second. And that's it. We're just going to leave that there. Actually, that's a lie. We're going to create a setup.js. Where does it recommend this? Yeah, so we're going to create a setup.js file inside of our tests folder. This test folder you'll see has a flag on it. I don't know if it like specifically looks for test/setup.js. My guess would be so. So probably this naming convention is important. But what they're saying is we need to run this piece of code down here, which says after each cleanup. Oops. Right, that doesn't exist yet either. All right, never mind. We are going to leave this empty for now. I feel like there was something else in here that they really highly recommended, but I think we're just going to leave it. Okay, so if I write a function like this, I probably want to write tests, multiple tests for this specific function that just tests inputs and outputs. We call this a unit test because it tests one independent unit of code that does not depend on anything else. We also probably want to write more complicated tests that test sort of systems that work together, called integration tests, or end-to-end tests, which say, I'm the user, I do this on your site, this should happen. End-to-end Doesn't matter what happens in the middle, I should expect a specific result. Most commonly, you'll have I'm just going to say it, you guys can handle it, a shit ton of unit tests, like a lot, for every single unit of code that you write. And the way we're going to do this is we're going to create a file that tests everything inside of our functions file. So in this case, it's only one thing, but I would probably write all my tests inside of a similarly named file, functions.test.js. I'm going to split screen this. Cool. So the way we're going to do this is we are going to use the testing infrastructure provided by vtest. So as programmers, we have come up with testing infrastructure that tries to mirror English as closely as possible in order to write a test that should execute. So hopefully, as we're writing these tests, it will be very clear what they're doing. You don't have to know like how it's doing it, but we should know just from reading our tests top to bottom exactly what's happening in what order, and there should be no hidden quirks or features or really complicated code that doesn't make any sense. So one way we do this is we use a describe block first. So a describe block takes in a string that describes what is this test we're writing. So we are testing that count letters returns the number of occurrences of, can't spell occurrences today, of each letter. And this describe block takes a function that it runs. So we sort of nest these together, blocks inside of blocks, that eventually will compose our whole test. And inside of a describe block, then we can use an it block, which is what should this particular test do? This test, or rather it, will do something. And so then we can give it a name and say, what will it do? Well, let's say we want to returns, or it should return the correct count for a string. We'll do an empty string first. And then inside of this, we give it another function. And this is the actual function that's going to run our test. And so inside of here, we can execute some code. Normally, our tests are going to follow this structure. Doesn't always have to, but I think this is something that we can strive for in general. Actually, I'm going to fix this. So our tests will generally follow the structure of setup, things, do the thing, and then check the thing, did the thing. So we're going to perform any setup, which means creating objects if we need to, or writing some data, declaring what our test is going to use in order to run. And then we're going to actually execute the piece of code that we're testing. And then afterwards, we're going to check and make sure that the result of executing is what we expect. So in this case, if I execute this count letters function with an empty string, I would expect that the result of this is going to be zeros all around. So let's do it. Let's figure out how we're going to do this. So let string equal to an empty string. In this case, I think that's the only thing we need to set up. We don't have to create any objects or anything like that. And then we're going to actually run our code. So we're going to call count letters on our string. And what we get back from this is we get back a frequency array where it has 26 elements and each one corresponds to a letter. And here I expect that all 26 occurrences are going to be 0 since there's no characters. There shouldn't be anything. So the really cool thing, I think like my favorite part about writing tests like this is writing expect statements. So expect is how you assert that a specific piece of data is what you think it's going to be. It has all the same properties. And the way we can do this is very sort of idiomatic. It makes a lot of sense. So I expect that my frequency array, the index at, or the item at index I, which is a number, I expect that this number is going to be equal to 0. And if it's not, I can provide an extra message here, wasn't equal to 0. And that's it. That's our whole test. So this expect statement accepts a value, which in this case, it's casting to a number for us, like behind the scenes. You can expect any value. You could expect an object, an array, so on and so forth. If I expect on a string, well, now the type of this expect that it casts to is a string. And I have different things that I can assert on it. Actually, I think it's just going to let me assert everything regardless. Never mind. But it doesn't really make sense that I would be asserting that this string is not a number or greater than something. It would make sense that I'm asserting this string has length equal to 0. This would be a correct assertion. And so these tests run the describe statement, which is like setting up your testing suite. That's what we would call it. And then it runs each test individually and runs it to completion, checks all these expect statements, and if they work, great. If they don't work, it doesn't let us pass. So let's run this. Let's see how this goes. So our command was npm run test. It's going to run vtest. And now it's going to pick up our test file because it's suffixed in .test.js. And it's going to tell us that this test failed. This returned the correct count for an empty string test. It failed because count letters is not defined. I did not import this. I have to export this function for this to work. So I have to export it from this other folder, and now it should import our count letters function. And it watches the test once it's running. So if I save, it's going to run all my tests again. If I didn't want to do that because they were really slow, then I would just hit Control-C and stop. Cool. And if I have an expect here that doesn't work, then it's going to catch it and say, expected empty string to have length 1, but it was 0. So all of our tests that fail, we can look at and understand why they fail. And then we could write some automation that runs this script when I push my code, and it runs all the tests and it does something if any of the tests fail. Maybe it sends you a message that says, hey, your code doesn't work, fix it, or it prevents you from merging in your code, or both. Sometimes it's both, stuff like that. It cannot see the function count letters unless I export it, which is what I forgot to do. So now we're importing it as expected. Cool. Any questions so far about this basic testing infrastructure? This is one test. We're going to write some more tests in just a second here.
Hi, Eli, and everyone. I just wanted to ask, like you can put as many tests as you want in one describe, right?
Yes, a describe should have multiple tests in it. This is a description of I'm testing this one thing, and then your it statements are each individual test that tests a different component of that thing. So in this case, we're testing that it works for an empty string. Maybe we are going to write another test for if it's, a very long string, something like that. Those should be in multiple its, but you should have multiple its in a describe. That's what it's designed for.
And you chose this specific vtest because it specifically works with Vite the
Yes,
best.
it's designed to work with Vite, and it supports React, it supports other JavaScript frameworks. It's sort of like how we're using the Vite as our launcher, as our build tool for React, instead of create React app, which has caused some confusion in the past. Vite is kind of like a more modern version of create React app that's a lot faster and does things much smarter. And similarly, vtest is sort of a superset of an old testing library called, I think Jest is what it's replacing.
Yes, Jest. Cool, thank you.
Unit tests are not necessarily local. All of your tests are going to be defined in files in your code base. And your CI/CD pipeline, which stands for continuous integration and continuous deployments, which is just like all the automation that runs between you pushing your code to Git and it arriving on your website server and running in production. All that automation just runs your tests as you configure it to run, to make sure that before it tries to push your code to a server somewhere and run it, that all of your tests are passing. So there's not necessarily a concept of like local or public for tests. It's all there. You can run it yourself on your computer if you want to, or you can set up a robot that does it for you. But they're going to do the exact same thing. They're going to call this same command that we're running. All right, let's write a couple more tests really quick. So we did this. It works. This test case is fine with me. Let's write another test case. So I am thinking of other tests that we're going to need. Can you fail a unit test and still be able to push it up? Depends on how you set up your automation. Maybe you set it up so that it completely prevents you from merging your code. That's typically what people do. They'll attach it to GitHub and say you cannot submit your merge request until everything passes. That's what we do at work very often. But if there's a test that you don't want to run all the time, or you, for some reason, you just want to ignore it, then maybe you set up your automation so that it doesn't care. Up to your use case and what your team agrees on. All right, I want to try and run through this pretty quick and then get back to the other just like review questions that I skipped a while back. What kind of tests for CID pipeline? This is it. This is the step you're running on your pipeline, on your automation. There's not anything that you would write specifically for that. Anything you can run locally, you set up your automation to run. Okay, so let's think of some other cases that could potentially break my function that I want to make sure that I write a test for. Anything that you think could be a tricky input or causes some different branch of logic in your code, you should be writing a test for. So if I had like an if statement that had 3 different branches, so if do this, else do that, then I need to write a test that covers all 3 of those cases. In this case, I think weird things that could be given to this function would be an empty string, which we already did. Maybe I have a really long string. What if I gave it like really weird characters? So right now I assume that all of my characters are in this alphabet, but what if I gave it a string that had uppercase letters? What if I gave it one that had mixed upper and lowercase? And what if I gave one that had random symbols? Then what happens? So let's do this. Let's write our next test, which will just be that it works for some arbitrarily long string. So we're gonna change this title. I would not recommend like naming it with the same prefix over and over again, but I just want to make this read like English. And so I'm going to do it. I would probably name this something a little different in reality. Or a long string of lowercase letters. So in this case, my string maybe is just going to be a bunch of random letters. Actually, I have no idea what the count is here. Cool. So my expected frequency, we're going to set up this array and we're going to do this really, really stupid. What I would do if I had more time is write a helper that could create what I'm going to compare against. I essentially want to create a separate array that has all the counts that I expect, and then I can just do a direct comparison of the two arrays. But I don't really want to put 26 elements in here by hand. That's not going to be readable. Like if I do that, and then I put a random 0 in here somewhere, you are not going to be able to look at this and say, oh yeah, that should be 0 M's. You're going to have to like go in and manually count by your hand, and that's not going to fly. So instead, we're going to write some code that makes it more clear. So we're going to say for I is equal to 0, I is less than 26, I plus plus. We're going to fill this all in with ones. And then we're going to say, well, we have 4 z's. So our expected freak of 25, which is our z, well, that's going to be 4 instead of 1. And then we count our letters, and we make sure that frequency of I is equal to our expected frequency of I. One convention that I like using that I learned literally this year from my job is that the thing we're comparing against, we normally call expected. That's what we expect it to be when it comes back. And then what I would name this is actual frequency, which is I ran my code. In actuality, it's this. Is that correct? I don't know. And you're comparing, is my actual frequency equal to what I expect it to be? So expect that my actual frequency is equal to my expected frequency. Wasn't equal. And so now if I run this test again, cool. So both of these work. I have 2 tests that pass. Everything looks good to me. It's waiting for file changes. If we had more time, I'd write more tests. I would absolutely not submit this code unless I had a test for all of these cases. And if I submitted without one, my team would tell me, you're not writing enough tests. Go write a test for this other case. Super, super important. You'll be doing this in any computer science job, not just like if you're doing backend or front end. We also generally want to write tests for really complicated React components. So like if I have my app component and it does a bunch of interesting stuff, I could write tests using vtest and JSDOM, which is this other link that I sent to you. They're writing a test here that describes, am I rendering my app component correctly? This tests that it renders the headline correctly. And so we render this component And then we write some code that checks, do I actually have the right thing on there? We're not going to do this today. Maybe we'll do it another week. But this is probably more relevant to what you're doing right now. You could write some tests for your to-do list component and make sure that when I add a new one, it puts another one on the screen. And when I delete, it takes it off the screen. You could write automated tests that do that if you want to. Be a good exercise. Okay, can you write a unit test for a login function? Yeah, you can write unit tests for code, like any function you can write a unit test for. You may have to do some really crazy finagling in order to get it to work. If I have a function that depends on outside data, like maybe it goes to my database to check if a user exists because they're trying to log in, I don't want to do that in an automated test that I'm running over and over again because I don't know if that user always exists. I don't really want to mess with my production database because if my test accidentally breaks it, then my production website is now totally screwed. So there's something called a mock. A mock says this object that normally does this really complicated operation, I don't want to do it for the test. I just want to pretend like I'm that object. And when you tell me do that complicated thing, I'm just going to give you a piece of data arbitrarily and not actually run anything complicated. So you might write a mock for whatever object performs your authentication and sends out those requests to the internet. And instead of doing that, when you call login, it's just going to tell you whether it worked or not. And you can tell the mock, when I try to log in, fail for me, and then use that in your test to say, does the rest of my code react when this thing happens? That was not a great explanation. Definitely consider reading about that. That's also really important. I don't think you'll be needing to worry about that anytime soon. But it's a very, very, very important thing for writing tests in production. Cool, it's 8 o'clock. I want to go back really quick and answer a couple questions really quick from the React stuff further up. Feel free to drop off. I will, of course, post this recording as always. Please make sure to fill in the login, the attendance form, just so I know that you were here. And I will see you guys next week. All right, so going back to earlier questions, there was a question from Anuha. Is there any specific situation where you would use class components over functional components? No, you should not use class components anymore for new code. There might be cases where people wrote a React website when React was first invented and only class components existed. And so the code has been around longer than functional components. Functional components were not introduced at the start of React. They were introduced a couple years ago. At this point, you should be writing any new code as a functional component. But you might end up working with a team on a project that predates functional components, in which case you'll have to write some class components, or at least know how they work and be able to maintain them. Yeah, and then that was the other question, why use a promise when you use async await? Generally, you will not be writing a promise. You will be handling a promise that someone else wrote in their code. So when you use fetch, which you'll do in the next lesson, your fetch returns a promise. So under the hood, they are creating a new promise object and then fetching data from a server somewhere. And when it comes back, if it works, then they will resolve their own promise, or they will reject it if it didn't work. But you don't have any control over that. You just deal with the results. So because they return a promise, then we use either .then and .catch, or we can do await, fetch, and put this inside of an async function. So these are two different ways of handling a promise. You will generally not write a whole lot of promises yourself, but you will be handling them literally all the time. Between these two, usually it's just preference. You can do the exact same code with either one. But I think this fetch, then, and catch tends to get really messy because if you have multiple things that depend on each other, like maybe you send a web request to check if something exists, and then when it doesn't exist, you send another one to create it. Well, the way you'd have to do this is you'd fetch, call .then, and then inside of here, you'd fetch again. And then call .then. And I don't know, maybe you do it another time just for fun. I think this is really gross. You're indenting like crazy. I think then and catch is usually good if it's just like a one-off. But if you have code that needs to be readable and does a lot of different asynchronous stuff in a row, then I would usually recommend using async await, because await lets you run your code synchronously. I can fetch multiple things in a row and do some stuff in between if I want to. And I know that it will execute top to bottom. So it'll fetch, it'll wait, it'll fetch, it'll wait, it'll fetch, it'll wait, and execute things top to bottom. Depends on your use case. The more you do this, the more you'll get a feel for when to use which one, which you like better. Yeah, write all the arrow functions you want, man. You could write every single function you ever write as an arrow function. I know people that do that. I personally like using function like when I'm declaring either a function inside my component or when I'm declaring a component itself. But you don't have to. You could make all of your components arrow functions as well if you want to. I like using function because it clearly indicates that like this is a function that's going to happen. And then when I have something that I'm just like inserting into my tag, so like if I'm have a button down here and I'm handling an event, that's typically what I'll use an arrow function for, just because I want to be concise. But up to you. All right, any other questions while I'm here?
I have an off-topic question. I
Go
don't know
for
if
it.
somebody already asked you. How did you make this your VS Code look so colorful? Like, is it
All
plugin
extensions.
extension?
I
Okay.
have a couple. I have one for material icon theme, which actually I don't know what the difference between these two are, but this is what does all of my icons on the side. And then my theme that I use is from an extension as well. Most people will install material theme. This has a lot of options that you can choose from. I personally use Noctis instead, which is another collection of themes that are very like pastel-y. And then my theme is Noctis, which is purple. I like this purple color. I can't really use anything else at this point.
Looks very nice. Thank you.
Last questions. All right. I will send out the recording and links tonight in our Slack channel. So keep an eye on Grackle announcements, and I will see you guys next week. Have a good weekend.